branch alkyl groups. So if you want to use common names for the branch alkyl group, you have to know that numbering always begins at the point where the group is attached to the main chain, or you can call it parent. For example, here we have 3 examples. So here are the main chain or the parent, and these are the alkyl groups, the branch. So you start counting from this carbon because it attached to the bond of the parent. So this is carbon number 1, carbon number 2, carbon number 3. Same goes to here. Start from here, the bond to the parent, carbon number 1, carbon number 2, carbon number 3. And this one you only have 2, carbon number 1, carbon number 2. For the first common name, it's iso. So for iso, I give you 2 examples here. These are the parents, 7 carbon, the parents, so you call it heptane. And the bond, this is the branch, bond to the parent or main chain. So you start counting number 1 from this carbon. So it's propyl, total number of carbon are 3. Number 1, number 2, number 3. And iso. You have to know that iso is 1 methyl at the carbon before the last carbon number of the branch. So here you have carbon number 1, carbon number 2. So your last carbon number of the branch is carbon number 2. So the carbon before carbon number 2 is carbon number 1. You have 1 methyl at the carbon before the last carbon. So 1 methyl, this is methyl, at the carbon before the last carbon number of the branch. So your last number carbon is carbon number 2, and carbon before is carbon number 1. So you have 1 methyl, and we call it isopropyl because the total number of carbon are 3. Another example for iso. So let's say we have 4 straight carbon chain for the branch, and here we have 5 straight carbon chain for the branch. So you know that this is butyl and this is pentyl. Now, so you start counting from the carbon which attached to the main chain or the parent. So you start counting carbon number 1 here, carbon number 2, carbon number 3. Again, remember, iso is 1 methyl at the carbon before the last carbon number of the branch. So your last carbon number is carbon number 3. You have 1 methyl at the carbon before the last carbon. So it must be at carbon number 2 because your last carbon number is carbon number 3. So you have 1 methyl. The total carbon are 4. So it is isobutyl. For this one, total carbon number of 5. Start counting from here, carbon number 1, carbon number 2, carbon number 3, carbon number 4. 1 methyl at the carbon before the last carbon number. So your last carbon is carbon number 4. 1 methyl before carbon number 4 is at carbon number 3. So this is called isopentyl. Next, sec. Why is it called sec? Sec means secondary carbon. So you have to know that the carbon number 1 is secondary carbon. That's why we call it sec. So for example here, you have the branch butyl and this branch pentyl. Now, sec, another way to understand sec is 1 methyl at carbon number 1. So here, carbon number 1 branch, not the carbon number 1 parent, carbon number 1 branch. Remember that. Carbon number 1 branch, carbon number 2, carbon number 3. You have 1 methyl at carbon number 1. And note that the carbon number 1 is secondary carbon. This is secondary carbon. So the total number of carbons are 4. So it's butyl. And the common name for this branch is sec-butyl. Sec is secondary carbon. So sec, another way to understand sec is 1 methyl at carbon number 1 of the branch. This one, total number of carbon, 5. So it's pentyl, but it's not pentyl because pentyl is just a straight chain of the branch. So this is pentyl, this is not pentyl. So it's sec-pentyl because 1 methyl at carbon number 1. Another way of representing sec, it's not always from this side. You can have like vertical order. So sec-butyl. So this is carbon number 1. Always start counting the number of carbon from the bond that attached to parent. So this is carbon number 1, carbon number 2, carbon number 3. Now, the total number of carbons are 4. So it's butyl and it is sec-butyl because 1 methyl at carbon number 1 branch. So you have 1 methyl here at carbon number 1 branch. And for this one, sec-pentyl because 1 methyl at carbon number 1, pentyl because the total number of carbons are 5. Next, tert. It is called tert because the carbon number 1 is actually tertiary carbon. So as usual, the straight chain of the branch, 5 pentyl. If it's 6, you call it hexyl. So carbon number 1 here, start counting from the bond attached to parent. Carbon number 1, carbon number 2, carbon number 3. Tert. Tert is you have 2 methyl. For sec you have 1. But for tert you have 2 methyl at carbon number 1 branch. So here carbon number 1 branch, 1, 2. 2 methyl. So the total number of carbons are 5. So you call it tert pentyl. And this one, total number of carbons are 6. So it is tert hexyl because you have 2 methyl at carbon number 1 branch. Note that the carbon number 1 for both are tertiary carbons. Another way of representing tert, so as usual, carbon number 1, carbon number 2, carbon number 3, start counting from the bond attached to parent. And you have 2 methyl at carbon number 1. 1, 2. 2 methyl. Total number 5, total number of carbons, so tert pentyl. And this one, tert hexyl, 2 methyl at carbon number 1. The final one is neo. Neo is when you have carbon number 2 branch. Carbon number 2 branch is quaternary carbon. So this one is just a straight chain of 5 carbons. So it's pentyl and this is hexyl, just a straight chain. This one, you have carbon number 1, carbon number 2, carbon number 3. Neo, 2 methyl at carbon number 2 branch. So 1, 2 methyl at carbon number 2. So the total number of carbons are 5. So you call it neopentyl. Pentyl 5. It's neo because you have 2 methyl at carbon number 2. Next, for this one, total number of carbons are 6, so it's hexyl. You call it neohexyl because you have 2 methyl at carbon number 2. 1,2-methyl carbonamide.